Hello everyone, Robert Garza, back again with another malware analysis video. So today we're going to have another look at Wannacry. In my first video, we took a look at three different ways in which you can extract the kill switch. And today we're going to have more of a deep dive in Wannacry. So we're going to have a look at the binary and see how it interacts with the file system. We're going to extract some hashes and key network indicators that you can use to help protect your environment. And lastly, we're going to have a look at the persistence mechanisms, or rather lack of persistence. So this WannaCry variant, there were some issues with it when it was initially released I think it was last summer. All right, so here's the reverse set or the hash that we're going to be taking a look at today. Um, so as I was saying, the malware authors they messed up with this version in regards to the persistence mechanisms. Doesn't actually work, and also the kill switch. There's actually no kill switch for this version as well, and we'll see all that as we take a look at this. All right, let's get rid of this. Oops, that's not what we want. Oh yeah, I also wanted to mention this variant. It actually doesn't need a network connection um, to call out to a C2 server to encrypt your files. It actually has the encryption key already built in to the binary, so that's quite interesting. All right, so let's go ahead and get started. I've already got it extracted right here on my desktop. So, oh, and just a quick video disclaimer. I'm somewhat new to creating videos or video development and whatnot, and I don't use any video editing software, so please excuse any errors or mistakes. So obviously, I'm not going to be going back and editing those mistakes out. All right, so with that, let's get started. All right, so first things first, I'm going to go ahead and stop my Splunk universal forwarder. Otherwise, we're going to get a lot of noise in the background when I run these programs. So, all right, we got that stopped. So we're going to go ahead and use, we're going to run Wireshark in the background, obviously. And then we're going to use Process Hacker. Have this running in the background. And what else? Oh yeah, we're also going to use Flypaper in this demo. Before, when I was analyzing this malware, I was having some issues with some of the child processes. They would close right away, so I couldn't get a chance um, to analyze them further. So what Flypaper does is it stops some of these programs from closing. We do want TCP/IP. We don't want to block that. All right. Let me just make sure this is okay. Collecting network information. We can close this. All right. Let's go ahead and we'll drop this to the desktop. Start Flypaper and let's execute Wannacry. All right, right away we see some child processes being spawned. Now this variant this encrypts file system rather quickly, as you just saw. Okay, looks like we just got another child process. We got this annoying pop-up here. So right off the bat, some of the indicators that we could search through is to see where this is actually going to reach out to. Um, if you do choose to reach out to the bad guys, you can see where this connection is going to be made at. This connect us or check payment or decrypt. Um, for right now, let's go ahead and suspend um, this process so we can have a closer look at this. All right, so as you can see, there's a lot of files that have been written to the desktop here. So let's go ahead and look at this first child process. Have a look at this, see what's been written to the memory. Let's open this up, have a look. So right off the bat, I see a lot of information about the system, which is expected. A lot of cmd.exe, and that's probably in regards to the other child processes in that chain that we see here. Right, so iCalcs, there's nothing too interesting in that one, so we'll go ahead and move down to task dl.exe, and I'm not sure if we're going to find anything too interesting in here as well, but we'll have a look at the strings anyhow. All right, so scrolling down here, I did see a couple references to PowerShell, but other than that, there's nothing else too interesting. Looks like this memory string is just designed to invoke the next child process in this chain. So with that, let's go ahead and take a look at this process. Wanted to decrypt door. Let's close that one out. All right, this definitely looks a lot more interesting. So we're seeing a lot of references to Tor, which right away indicates that this particular binary probably has its own version of Tor built in. It's using that Tor version to communicate back to the attackers, the bad guys, and we should see that as well in the Wireshark PCAP as well. So continuing down, so we definitely see some references to that pop-up. Just shows how it's being displayed. Contact us, how to buy Bitcoin, about Bitcoin. So that's all in reference to the annoying pop-up that we're seeing. All right, then scrolling through the rest, there's not too much more information here that we can use. Well, as far as key network indicators that we can use in our environment. You could block that Bitcoin address, but that's not exactly what we're looking for. All right, so let's move on to the last process here. Task hsvc.exe. Let's have a look at these strings. All right, so this is looking much more promising here. So we see the bootstrap. So typically this is what happens when we see a binary that's establishing a connection or communicating with Tor. And then obviously we see some IP addresses here. So these are going to be some key network indicators that we can definitely use. So actually what I'm going to go ahead and do here is use a regex. Alright, so I just Googled a quick regex to filter out for IPv4 addresses, just to make this easier. So we can close this, yes. There we go. This looks a lot better now. So we can have a look at this now. So this is looking good. As you can see, we have a huge list here of what appears to be Tor directory services or servers that we can definitely use as network indicators. We got a huge list of IPs that the ransomware is probably using to communicate over. Some more Tor directory servers. All right, so that's it with that. You know what I would do next was probably just save it. Save it to a text file, maybe clean it up a little bit, sort it and whatnot. Then you could definitely use this, these key network indicators, and block that on your local proxy to protect your environment. So the next thing I wanted to show you was the persistence mechanism. So we can use auto runs and we can have a look at that. Alright, so let's go ahead and make this bigger. We want to look at see if there's any scheduled tasks, and it doesn't look like it. Persistence, so we click on log on. So right away we see this this big red flag here, or actually yellow flag. It's highlighted here. HKLM software Microsoft Windows current version run. So obviously that's a very popular run key that attackers or the bad guys like to use. And as we can see, there's an error with it. This is file not found. See that uses Robert desktop task schedule.exe. And we can see where they messed that up here in a second. Here I'll show you. But other than that, we don't see any other indicators that we can use. Or it's interesting. So we'll go ahead and close this up, and we'll see where this file is actually located here in a second. All right, so as we saw earlier, there was a bunch of files that were being written to the disk, specifically on the desktop. And one of those folders was right here, test data, data Tor. There's nothing in that one, but if we go back to this folder, here we see this is where actually that task hsvc.exe actually lives. So it looks like that's probably where the malware authors messed up. So if we go back to auto runs, we could see, log on, expand this. So they actually specified that the task SHE executable would be written right on the desktop, and as we see, it's actually written in this folder right here, task data.tor. So it looks like the bad guys actually made two mistakes there. So they probably had a typo there, and as we saw in auto runs, it was called task sh svc.exe, and also looks like the bad guys specified the incorrect file directory. All right, so um, I guess some more indicators that we could get from this malware sample is we can go ahead and hash these files. So let's go ahead and do that. As you can see here, tor.exe and svc.exe, they have the same hashes, so that's definitely probably the Tor binary that's is being used to communicate back to the bad guys. So that's about it. You just wanted to show you a quick way how you can collect some hashes to protect your environment. But hopefully your environment's already protected, as this is an old malware sample. So let's have one look at Wireshark before we wrap this up. Hopefully it's still running in the background. So let's go ahead and have a look at DNS. Let's make this bigger. So not a whole lot there, nothing interesting. Next, we want to look at, obviously we're going to see some Microsoft stuff in here. Not a whole lot though. Let's look at TCP, and probably going to see a whole lot of conversations going on there. So obviously we're not going to go through this entire PCAP. It's just recommendations. What you would do is go ahead and save this PCAP. Extract those key network indicators. You could also compare this. Excuse me. Thought I saw something I wanted to look at. Yeah. Anyhow, I mean, if you look at TCP, there's going to be a lot of conversations happening where the malware is trying to communicate out to the bad guys. So as I was saying, say that PCAP and extract those key network indicators, and you could compare those indicators with the indicators that we collected from the memory strings. I believe it was from this process right here. Under the cmd.exe, we collected some good network indicators, so you could compare those IPs and make sure you got everything you need to protect your environment. So just to recap, I'm gonna go ahead and wrap this up here. So first, we executed the binary, obviously, and we reviewed all the child processes, and specifically in this child processor here, one decryptor. Under the CMD executable, we collected some key network indicators in the memory string that we can use to protect our environment. And we had a quick look at Wireshark. We saw a lot of conversations. We can obviously take that PCAP and use those IPs as well to protect our environment. And then what else? Oh, we also looked at the persistence mechanisms, or rather lack of persistence mechanisms. And that's about it for this demonstration. If you're interested in the Wannacry samples, have a look at my other video that I demonstrated. We took a look at 3 different tools that you can use, or 3 different ways, techniques you can use to uncover the kill switch. So that's a pretty cool video. And so in that one, we actually I used my Remnux box and use some different tools. So I suggest you have a look at that video. And if you're interested in how I use any of these other tools for malware analysis, I've got plenty of other videos. There's some really cool stuff in here. Burp Suite, fake DNS. We already covered auto runs in this video. PE Studio, hex editing tool, Procman, Microsoft Network Monitor. Anyhow, yeah, I've got plenty of other videos up where I demonstrate these tools. So thanks again for watching, and stay tuned for more malware analysis videos. Thanks.